Alright, so we're going to graph secant and cosecant, and these should be pretty simple because it's basically just the same thing as graphing sine as cosine. But anyway, so whenever you're graphing secant, you're first going to look at the corresponding graph of secant goes with cosine. So you're going to look at the cosine graph. Now, secant we know when we evaluate on the unit circle is 1 over x. Okay, so we can also think about that since x is just cos. I can think about this as 1 over cosine. So we've looked at fractions or rational expressions before, and since you can't have 0 in the denominator, you have a vertical asymptote when cosine is 0. And so this means you're going to have vertical asymptotes. When we graph, I just want you to graph a positive period and a negative period. So that's one trip around the unit circle in a positive way and one trip in a negative way. And so when we graph it, you would have your original asymptotes at cos is going to be 0, so the x is going to be 0 at pi over 2 and 3 pi over 2, or negative pi over 2 and negative 3 pi over 2, so I'm just going to write plus or minus. So now we can represent all these asymptotes, and I'm going to go ahead and just introduce you to this little notation right here, just because you're going to see this when you get to calculus, but if you don't get it now, it's really not that big of a deal. But you can represent all the asymptotes of secant with a certain notation. And so I'm going to show you that notation. Let's pretend we've got our unit circle here. Here's pi over 2, here's 3 pi over 2. So all of the asymptotes on this function happen at multiples of pi over 2. Okay, so 1 pi over 2, 3 pi over 2, 5 pi over 2, and so forth. So what I'm going to do is write this as all of them happen at some kind of pi over 2's. So we're going to represent them all as saying pi over 2 plus n pi, and I'll go back and explain that. Where n belongs to, you have different sets of numbers. So we've looked at real numbers. Okay, reals is just represented by this little symbol. Now we're going to look at, we want n to just be, we don't want to like have weird like 1.3 as a number that could go in front of pi. I just want integers, which means like -1, -2, 0, 1, 2, 3, all nice whole numbers that can be negative or 0. So the set of integers is written with that little z symbol. Okay. So basically what this means is that pi over 2, if I put 0 in for pi, then that would be saying like pi over 2 plus 0, and so right there would be an asymptote. If I were to plug 1 in, then that would be like saying pi over 2 plus pi, which would just be half a circle, which would take me down here to 3 pi over 2. Now, if I had pi over 2 plus, let's plug the integer 2 in, so 2 pi, that would be all the way around, and that would end up giving me a 5 pi over 2. If I had 3 pi, that would take me another half of the circle down, okay, and that would end up at 7 pi over 2, and you see what keeps on going. Now, same thing if I were to put a negative number in. Let's say I put pi over 2 plus negative pi, so that's like pi over 2 minus pi. Pi over 2 minus pi would take me back down here, which would take me to, instead of 3 pi over 2, a negative pi over 2. And so anyways, you're going to see this notation some in calculus. Like I said, if you don't get it now, it's really not that big of a deal. But regardless, this is how we're going to represent all the asymptotes of secant. Okay, the main thing you need to know is that they're at pi over 2 and 3 pi over 2. Now let's graph 2 full periods of this secant function. So I'm going to look, starting out, I'm going to pretend that I'm graphing cosine, because secant goes with cosine. So the amplitude of this is 3. The period would be 2 pi over 1, okay, because the number in front of x is just 1. And so this is just 2 pi. So I'm going to go label all that stuff. So this is 2 pi, negative 2 pi. This would be pi and negative pi. And so amplitude goes up to 3, down to negative 3. Alright, so then I'm going to graph this cosine. I'm going to graph it like it's cosine. So I'm going to put the points on this graph as if it were cosine. So cosine starts up at a max, and that would be at 3. So max, 0, min, 0, max. Then on the other side it would go 0, min, 0, max. Now, I'm not going to graph this cosine. I'm not going to connect those points because this isn't cosine, this is secant. So secant, we said, has asymptotes wherever cosine equals 0. If I were to connect this, cosine would equal 0 at all of these places where it crosses the x-axis. So I'm going to go ahead and put asymptotes wherever there are points that are on the x-axis. So all of these places where the cosine would cross the x-axis is going to have asymptotes. So now, all this does, since secant is a reciprocal function, normally you would have this little u part right here. But since this is a reciprocal, it's just going to take that little u part that was like this and flip it up. And so this would now be what your secant graph looks like. So anytime there's a max, you're going to have a u pointing up. Anytime there's a min, you're going to have a u pointing down. Here, we're just graphing to the 2 pi, so I'm just going to graph that one side. And then this would be going down. I made that one a little far out there. And then this one, I'm going to graph like this. Alright, so then these, I call these lobster claws because they look like a lobster claw. Anyways, so our little lobster claws are going up and down, and this one's going to start up because this was cosine. We started at a max. So there's our secant function. Alright, so now let's go graph cosecant. So when we graph cosecant, you got to look at the corresponding graph of sine. Okay, since cosecant goes with sine. So we know that cosecant is 1 over y, or I can think about that as 1 over sine. So can't have 0 in the denominator. When you do, you're going to have vertical asymptotes. So when sine is 0. Now sine, or y, is 0 whenever you are at 0, pi, now I'm going to go ahead and write plus or minus, and at 2 pi, plus or minus. So you can represent, if you look at all of these asymptotes, these are just multiples of pi. So you can represent all of the asymptotes of cosecant with just n pi. Okay, so if n is 1, you'd have pi. If n is 2, you'd have 2 pi. If n is 3, you'd have 3 pi. If n is 0, you'd have 0. Negative 1 would be negative pi, and so forth. So this one's a little bit easier to see, I think, than the last one. But where n belongs to set of integers. And so that's how we're going to represent all of the asymptotes of cosecant. Now, we want to graph 2 full periods of this cosecant graph. So this is going to be, I'm going to say this is 1, negative 1. So 1/4 we'll just pretend is like there. Alright, so amplitude is 1/4. Period is 2 pi over 2. So that's just pi. So out here I'm going to put a pi and a negative pi. Divide it into 4. And so this would be pi over 2 and negative pi over 2. Now, I'm going to graph this like I'm graphing sine. So sine always starts at the origin. And since this is positive, I'm going to go up to a max first, at 1/4, 0, down to a min, 0, min, 0, max, 0. So now, at all of the places where sine would cross the x-axis, I'm going to put asymptotes. So asymptotes. And so then, wherever there's a max, I'm going to have an up lobster claw. Whenever there's a min, I'm going to have a down lobster claw. So I'm going to go lobster claw it. Here we go. And boom, boom. Down, down. Probably could have gotten a little closer to that asymptote there. And there you go. So those are your 2 full periods of cosecant. And that's all.